Hello everyone. In this session we are going to discuss about the linked list implementation of circular queue. In the previous video related to this topic we have seen how we can make use of array. So in this class our focus would be on linked implementation. So before moving to the linked implementation, as you would have seen the linked list in a circular way, like circular linked list we call it, how it is different from this implementation that we are going to discuss. See, a circular linked list is also having the nodes where some data part is there and address part is there, which address part refers to the next node. But there are certain differences. The very basic difference is we make use of head and tail concept in case of linked list, circular linked list, but in this case we'll make use of rear and front labels to represent the insertion and deletion part of the circular linked list, and the operations are also limited in this case because in case of circular queue, as we are giving only one option, rear end to insert and front end for deletion, we have only in queue and dequeue operation like insertion and deletion operation only, and insertion we cannot do in between the queue. Okay, we are not going to insert in the middle, we are going to insert at the rear end only. Okay, and similarly for front, at the front position only we will insert. So wherever the current position of front or rear is there, there only we are going to provide the operations. But in case of circular linked list, anywhere at the end, at the beginning or at the middle, we can add element. Okay, so these are some points where we differentiate between the circular linked list and the circular queue concept implementation through linked list. Otherwise they are going to be most of the time same. Okay, so let us understand how we can implement insertion. See, I am going to cover this topic a little bit faster because you would have seen the details of linked list already in the unit 1 and in unit 2, where you know the concept of pointers we need to apply. We take a structure where some data part is there and address part is there. Okay, in the case of circular queue implementation through linked list, we make use of a pointer called front pointer, okay, which have or keeps the address of element at the front of the list. Okay, that the terminology we use in case of queues. Rear will again be a pointer which will have address of last inserted element in the queue. Okay, and one more concept we need to add it, rear may point to the front. Okay, because in order to make it circular, the rear pointer or the node present at the rear position will also have address of the front node, so that we can make it a circular. Okay, so the usual process that we apply, that we create a new node and then dynamically and insert a data to that using the some structure format that we use. Okay, and when the list is not created, initially there is no node, so at that point of time front and rear, in case of array implementation they were set to -1. In this case we are going to set them to null value because there is no data present, so initially they contain null address. Now this example shows when we have only one element, how it would represent a circular queue using link node. So we have only one element and the value of that element is 10, and in the address part of this particular element is the address of the front. And what is front? front is having the address of this single node only, and rear is also having the address of this single node only, because there is only one element in this circular queue. Okay, this is how conceptually it is represented. See, every time front should point to the first inserted element here, like the element which we have inserted, and at any point of time we want to delete it, that would be deleted, because it follows the first in first out strategy. And then rear will keep on moving ahead as we keep adding the elements. Okay, along with these two, we need to also ensure that the last element which is pointed out by the rear also contain the address of the front element in order to make it circular. So all these three conditions are met here. Front and rear, because being only one element, points to the same location, and address part of this only single element points to the front. Okay, or you can say the node itself, because there is only one element. Now if we add one more element, let us make it 2. So what are the changes? What changes we need to make? This element 20 we create separately, maybe we create it separately, and then we try to add that element here. So in order to add it, what we do, the pointer which was earlier pointing to this front, now it will point to this newly created node, and this newly created node's address part will contain the address of the front. Okay, and what other parameter needs to be changed? This rear will move ahead at place of pointing to this last inserted element, because now this 20 becomes the last inserted element, so rear points to this. So these three kind of changes we need to perform at the time of insertion. Similarly, if we add one more, this new node's address part will contain the address of the front, and this rear will change. Rear will now point to this newly inserted element 30. Okay, and front will not change in case of insertion process. Again we added another element 40. This rear changes from like it starts pointing to 40, because this is the last element now, last inserted element, and in the address part of this last inserted element is updated with the address of the current value of the front. So that is given to this part. So keeping this concept in mind, we'll see how we write a C code for implementing circular queue using linked list. So what we are doing here is, we are performing this insert of we are implementing this insert function where a structure has been defined. We'll see in the demonstration part how the structure is defined. Actually it will contain two elements, one is like data part and another is address part. So that structures variable we have created, pointer we have created star ptr. Through dynamic memory allocation we allocated the space for one node, and then we asked for the element value to be placed in that node using printf scanf, and then using the pointer notation we assigned that given value to this info part, which is again the element of the structure node, and link is address part of the struct node. It is set to null because we are not aware at that point of time what will be the address of the front. So this is how we prepare a node. Now this prepared node is to be inserted in the circular queue. For that insertion, first of all we check that whether we are going to insert the very first element of the circular queue or already it is having some element. So in order to check whether it is empty, we'll check whether front is equal to null. Front will obviously be null if there is no element, because initially front and rear both are set to null. So front is null. In that case, the address of the newly created element is the address given to the front and rear as well. Both will have the same value, because this is the only one element present, the very first element we are going to insert in the circular queue. So front will contain the newly created node's address, and it will not go to the else part, but this last statement will execute rear is equal to ptr. That means rear will also have the address of newly created node, so both front and rear will point to the same when it is the first element. And finally that last element points to the first. For that process we are using this statement that rears, that whatever last element's address is, at that address whatever node is available, that node's link part will contain the address of front. Okay, that we assign. So you can relate this statements with the concept that we have seen in the last example, like this pointer contains the address of the front. This process we are going to implement by this statement, rear link part is equal to front. So in order to make it circular, that connection we are going to apply here. Okay, so this is how we implement insert. Then in order to understand the deletion process, we need to see if front is null, what we will delete. There is no need to delete anything. So queue is already empty, then we can return simply. Now if front is equal to rear, that means they are at the same point. So if they are at the same point, that means there is only one element, and if there is only one element, we need to reach to a situation which indicates that after deletion of this last one element, the queue is going to be empty. So in that case we'll set front and rear both to null. Otherwise this is a normal case. We can delete the element and there are more than one element present in the queue. So in that case we'll move the front pointer from current position to the next position, and the previous position we can free, or it would be automatically garbage collected. For example, if this is the current scenario of a circular queue where we want to delete this value 10, because we always delete from front, so only 10 we can delete, and then after we can delete 20. So one by one we can do this. So we'll select the front position, and this queue, circular queue, is having more than one element, so this would be the third case. What we have to simply do, that we need to increment this front, like at front position whatever node is available, that's node's link part. Okay, the link part of that nodes should be the new value of front. Okay, this is how we update. Front initially pointing to 10, but now it should point to 20 after deletion. So what we are doing, we are accessing this particular block's address, whatever address is stored here. The address stored here is the address of this node 20. So now this front will contain the link part of the front. That's why I am writing here front is equal to link of front. So it will point to this new node. So that way this block would be out of this circular queue. So we'll reach to this situation. Similarly, if we want to move it out, then this part will contain the address of this node, and that address we can place in the front pointer in order to remove this. Okay, so that way we can reach to this situation. But in this case there is only one element, so rear and front both should set to null in this case, to indicate that queue is now fully empty. Okay, so this concept you need to keep in mind while implementing the corresponding code in C language. In this case again our structure node pointer has been taken, and if front is null, the queue is empty, no need to do anything, simply return. If front is equal to rear, there is only one element, in that case we'll set rear and front both to null. We'll free that particular memory location, and then we'll set the value of rear and front to null, so that next time if some insertion happening, that particular insertion can know about the current status of the circular queue. After that, if this is not the case, like it is not empty and even there is front is equal to rear, it is not having the single element, in that case simply we can set ptr equal to front and then increase the value of front and then free ptr. For temporary purpose we are storing this in front and then updating this front value, because it starts pointing to the next position and the previous position is freed, garbage collected. That way we delete the element. This is how we delete. So now let us see how we can execute this code along with that display function. We can see it would be very easy comparatively. So if we see, this is the same code. We generate a structure here, write a structure where only two parts are there, info part and link part, and these two values, first value will store the data and another value will store the address of the next node. Front and rear pointer of this structure type initially can be set to null. So this again a switch case statement for various operation in invocation through switch case according to the user choice. This insert function code we already seen, delete function we already discussed. Simply if we talk of display, how it is happening, that we have taken rear and front as a global variable, global pointers. So we read the current value of front in the PTR, and if it is null, that means the queue is empty, circular queue is empty, so we can display this. Otherwise it's not empty, then we need to display every element. So how we'll start the loop? While PTR link not equal to front, like whatever is the current value of front, if we'll keep on accessing one by one starting from front, we'll reach to the front again because of that circular concept. So that's why we are using this condition that PTR point to link should not be equal to front, because if it is a circular queue, obviously we'll see this condition sometime. So by using this condition we can access each and every element except the last one. So in order to print the last one, we are using this print outside, because it is accessing print link. So last link is not, we are not able to access. That's why this one printf statement is given outside as well. So this loop will display all the current elements in the list. Let us execute it. So again options are asked. Let us implement first one for insertion. The first option, insert. What we insert is 67, let's say. Again insert some value, let's say 54, and then if we want to see the status, it is showing all those two values 67 and 54. And then if we choose 2, and then for 2, that means it will delete the element at the front. So in this session we have seen the circular queue implementation using linked list. We also try to identify the minor differences of circular linked list and circular queue using linked implementation. Okay, and we also seen how we can use the C language code to implement the linked list version of circular queue. So we'll meet in the next video. Till then, thank you.